Imagine a maze with more dead ends than there are atoms in the universe. Calculating every single possible path is physically impossible, yet modern systems are finding the correct exit in seconds. When a human master sits across from an algorithmic opponent, the psychological weight of this leap is palpable. Machines are now routinely excelling at tasks that rely on deep intuition. In a game of Go, the total number of board configurations is vast. Identifying the winning strategy requires an ability to navigate an impossibly large set of possibilities, a trait we long assumed belonged exclusively to the human mind. For decades, our approach to computation was strictly mechanical. We built massive, physical machines to grind through calculations one rigid step at a time, relying entirely on raw mathematical power to secure answers. This creates a tension. Classical computer science theory states that for a whole class of difficult search puzzles, known as NP problems, we cannot calculate a guaranteed fast solution. Yet artificial intelligence models regularly output correct, highly complex answers almost instantly. We know these models haven't secretly broken the laws of mathematics. That forces us to look for a new theoretical language to explain exactly how these previously unreachable answers are becoming computationally feasible. But when that direct path shatters into millions of dead ends, we enter the domain of NP. Finding the true path from scratch becomes impossibly slow. However, if someone hands you a proposed map, a mathematical certificate, you can easily check if it works. You don't have to wander blindly through the entire maze. You only need enough computing power to trace the route you were given and confirm whether it successfully reaches the exit. Checking an answer requires a fraction of the resources needed to generate one. By relying on a structured proposal, an algorithm bypasses the need for an exhaustive, inefficient search. That raises an obvious question. If checking a map is easy, what happens when there is no map? How does a system find the right path when it has to generate the solution entirely on its own? This diagram illustrates what complexity theorists call the polynomial hierarchy. It maps out a ladder of increasingly sophisticated verification games, stacked layer by layer, extending far beyond basic problem solving. We can break down how these higher levels operate. First, the system makes an existential move. It generates a bounded, rough draft of a potential solution. Next comes a universal move. The system acts as its own adversary, aggressively critiquing the draft and exposing its logical flaws. Then, a repair step patches those specific weaknesses. Once the corrections are made, the structure is subjected to a strict, rapid mathematical final check to ensure everything holds up. By internalizing this continuous loop of propose, critique, and repair, the algorithm navigates highly complex search spaces. It constructs accurate answers, while operating safely within the strict boundaries of feasible computation. None of this requires an infinitely powerful machine. The system never relies on unbounded resources. It simply chains together finite, manageable layers of verification. This single pillar represents a concept known as a limiting process. It is the mathematical union of all these progressively richer, finite layers of verification into one cohesive framework. We see this exact framework in modern large language models. When an AI pauses to use chain-of-thought reasoning or reflects on its own output to correct an error, it is physically executing this structured, bounded ascent. The mathematical limits of computation have not vanished. These systems haven't figured out how to solve every hard puzzle uniformly. Instead, they have learned to identify structured pathways where adding the right guidance turns previously impossible regions of a problem into something reachable. Intelligence is not a mystical force that overrides the laws of computation. It is the mastery of this merification game, a method of scaffolding logic, step by calculated step, until the unreachable becomes possible.